Okay. Good evening, everyone. I hope you can all see me. Welcome to our NotEqual Summer webinar series, running in conjunction with our summer school on social justice and the digital economy. I am Clara Crivellaro. I'm based at Newcastle University Open Lab at the School of Computing. And I have been leading the NotEqual Network Plus in collaboration with Anne Light from Sussex University, Alan Dix from the Computational Foundry at Swansea, and Lizzie Cole-Kemps at Royal Holloway, University of London for the past 3 years. NotEqual is a £1.2 million UKRI funded Network Plus project that aims at exploring and creating the conditions that enable social justice in the digital economy. We have done this through enabling and fostering over 16 collaborations between academic and non-academic organizations and communities, as well as fostering many smaller and larger scales, events, engagements, and initiatives, resulting in new processes and new models for community engagement, as well as novel explorations and responses that we hope will advance justice and equity in our digital society. Our first summer school concerned digital security and algorithmic justice, and Anne Light and myself have worked together on this summer school, which has the added benefit of a webinar series with speakers from around the world addressing the broader theme of social justice and the digital economy. We recognize that notions and practices of and for social justice are evolving. So this summer webinar series explores 4 themes that developed through conversations amongst ourselves as we reflected on the way that the advent of big tech, the COVID-19 pandemic, and the environmental crisis is reshaping and changing what we understand as social justice, and therefore what we should do in response of these dynamics. The evolution of social justice in the age of digital network and machine learning is what our speaker will explore this evening. Tomorrow evening, you will hear a panel of speakers from around the globe reflecting on the challenges and opportunities that working towards more equitable digital economies present today. Wednesday evening, you will hear perspectives from academic and third sector practitioners on ways we can make data work for social justice. And finally, our last evening, Thursday evening, we will explore the critical role that imagination and experimentation can play in and for social change with the event on stories from our socially just digital future. Okay, thank you very much for joining us, and I'd like now to hand over to my collaborator, Anne Light, who will be chairing the session this evening.
Thanks, Clara. It's been such a pleasure to work with you and get to this point. Can I ask anybody at this point to start thinking about questions that we'll post them in the chat because we're in a webinar situation. I'd like to welcome the 22 delegates who are actually on the NotEqual Summer School and everybody else who's tuning in from everywhere else. As Clara has just said, we're looking very much at how the technology changes things, and we've got 3 really exciting speakers with diverse perspectives on really the state of art in technology. So without further ado, I'd like to welcome our first speaker, who's going to speak for about 20 minutes. So they're quite petite talks. And then, as I say, there'll be a short chance for questions and then we'll move on. So Irina is professor at the University of Copenhagen. She works across many disciplines, focusing particularly on the ethics of technology. She was running the Virtue Project, which was an EU project on how IoT developers enact ethics in practice. She's interested in responsible technology design, data governance, online information disclosure, and we'll talk about things that are creepy if we're lucky. So may I hand over and pass the floor to Irina. Please welcome, and it's all yours. Take it away.
Thank you, Anne. So let me share my screen. And let's see, this worked in the test. Let's see how it works this time. Okay, does this work? Yes?
Yes.
Looking good.
You never know in these contexts. But I should probably go to the beginning of my talk rather than the end of it. There we go. Thank you for having me. I'm really, really glad to be here. And as I was thinking about this talk, I actually decided to talk about something, some ideas that are very, very new rather than ones that I've been talking about quite a lot. So there will be just a little bit of creepiness, but not a whole lot of it. Sorry, guys. So let's see how this goes. And I'd be happy to take any questions and challenges. Like I said, these are very, very new ideas. So today, I wanted to talk a little bit about this idea that we need to think about AI differently. And we need to think about AI as a relational infrastructure, and I will develop this idea going forward. But let me start with just putting together, giving you some context. I mean, there are many stories these days about technology, its potential problems and potential positive innovations that it can bring. So no matter how cautious or critical we might be, every technology story is kind of full of hope. So we pin our hopes on technological development to lead us out of this morass of contemporary problems and into some vaguely imagined bright future. Now, I was born and grew up in the former Soviet Union during the height of Cold War and communist imaginaries of various bright futures. So I know they're usually gleaming and very organized. So here's the image from the Future of Life Institute, which talks about the benefits of risks and artificial intelligence. It's all very gleaming and organized, and it has numbers. But when we talk about, in particular, AI, and in particular about autonomous systems, there's a pattern. This was supposed to animate, and it did not, and this is very annoying. Okay, we'll see how the rest of it works. So the current technology du jour of utopian hopes and dystopian fears is machine learning, or AI to the uninitiated. There are many innovations in this space, much excited rhetoric, and so many failures that it's getting exhausting to recount them time and again. In fact, I've stopped actually changing my slides and putting new problems on because they're kind of all the same, but just the names change. So this one, what's actually covered up was that last April, the University of Copenhagen had some news about how artificial intelligence was the secret weapon to fight climate change. At the same time, and see now this is not working spectacularly, there was also some reporting about the fact that AI has problems with climate change, as in it's contributing to it. So a few months later, students at the University of Copenhagen decided to help and develop the tool to predict carbon footprint of algorithms. Of course, they created an algorithm. So it creates an interesting process of trying to fix the problem and then creating another problem while fixing the problem. This is common. There are many of these kinds of ideas. It's not that when we talk about AI and machine learning, these technologies, they're always just terrible, we should stop doing this. There are many great ideas here. So this is Google Health, and they've developed a really interesting system that looks at trying to detect particular types of problems in the eye. They developed it for Thailand and India because in these countries, there are just too many people, and it's very, very difficult to do this in a timely fashion. And the model performed incredibly well in the lab and sort of fairly predictably. It was super accurate in the lab, and real life was a different story. Sometimes it worked, sometimes it didn't. Context really, really mattered. Now, in many ways, we all know that, yes, systems and technical systems need to be situated. It's almost as if there are certain things that we know that just never quite make it to developing these technologies in a way that might work better. Here's another fairly common example. I suppose most of you have heard of GPT-3, which has been came out last year and was the latest natural language processing system. It's been hailed in different ways. It's been great. It produces text. It really is one of the largest models, and it's amazing. Of course, it has a fairly predictable problem, that is environmental disaster. It also requires enormous amounts of carbon to work, but it also has other problems. Religious, gender, racial biases, environmental impacts, ethical considerations. GPT-3 has got them all. So it used to be, if you wanted to demonstrate how AI and machine learning systems could fail in spectacularly terrible ways, you could use Google search, and that was fairly dramatic. Where you could, if you searched for, "she invented," there was a time when Google asked, "Did you mean he invented?" They fixed that, but it's kind of like a whack-a-mole problem. Now, GPT-3 offers a fairly similar opportunity to sort of easily point out the problems. Now, in the end, problems seem to emerge with impressive regularity. So here's, this is The Guardian from 2017. This is The New Scientist from 2018. This was from just 2020. At this point, it's not like these issues are unknown, and yet it's as if we can't simply fix the problem. But what's the problem anyway? I think that's an important question. What are we trying to fix? Now, here's the thing. Most AI projects fail to get out of the research lab, but many that do get embroiled in some kind of scandal. This one was in an impressive flash in the pan. Recently, last year, a new service called Genderify was promoted to, they were going to identify someone's gender based on their name, email address, or username. It had a fairly predictable problem. I'm sure I don't need to explain what that problem might be. You might be able to see that in the image here. But really, it made predictions that, well, had both gender and racial biases. Needless to say, they shut down their service pretty much within hours of launching. Sometimes the failures to get out of the research lab have somewhat significant financial consequences. So we've all been waiting for autonomous vehicles for a while. I really want an autonomous vehicle. Now, I like driving, but I spent a lot of time living in California when you drive for hours to get from point A to point B. My God, autonomous vehicles would be amazing. So there's places in the world where people really would like them. Now, the stories are still there. We're still waiting for autonomous vehicles. But if you actually look, most companies have quietly scrapped these projects, and the companies that were built exclusively on the idea had a recent trend of precipitously shutting down. It looks like autonomous vehicles are a nice idea, but we're not getting anywhere near. Sometimes the failures are big and loud, sometimes they're small and quiet. So I got this email this morning from the Human Resources Department here at the University of Copenhagen. And it said, in the beginning of May, the University of Copenhagen implemented the new staff administrative system, KUPA. Unfortunately, the transition has created several problems, which now accumulates tasks and prolongs response times in both the HR centers and DECO's HR team. This is perhaps, well, it's nice they're quite so contrite about it. And they explain what's going on. But what do all of these have in common? Where the last one simply looks like a failure to really take into account the situation, the context of what HR processes are like and what HR processes need to actually have helpful systems. In most cases, what we're looking are something that is relatively common. They're biased data sets, they're biased architectures. There's a lack of capacity to engage with potential broader implications of AI systems. There's a need for better, more ethical, more responsible, more responsive, more situationally aware design processes. All of these are problems in search of a fix. Now, I teach and engage with a lot of students in computer science and in data science and in machine learning. And when I teach all of this stuff to them, I am often asked by computer science students, okay, all right, we see the problem. Now, how do we fix this? And this question assumes that the overall idea is good. We just need to fix these parts that are broken, and we will achieve the promised goals of a better world. So this is what is, by systems theorists, called the broken part fallacy. When you see a malfunction, you first want to fix it, because you want to identify what's the broken part. Once you fix it, everything is fine. Now, the problem is that the debates across many communities dealing with developing, designing, deploying AI and machine learning are coming to acknowledge that problems are multi-systemic. They're bigger than a bug or a fix. Fixing a broken part will not fix a multi-systemic problem. And as Dave Lauer says, systems thinking is about relationships, not parts. It's not about bugs. It's not about problems. It's about relationships. So I've been thinking about relationships for a long time. I actually started my career thinking about relationships and really just being a relationship scholar. I was interested in how people relate and how they use technology to manage that. Now, suddenly, all of that seems to be coming back for me. So I thought, let's talk about relationships. Life is relational. We're made by the people we meet, by the systems we engage. We're made by our relations, close, distant, social, otherwise. What does it mean, really, to be constituted through relations instead of living among them? It means our choices, our concepts of opportunity and possibility are shaped by the wider networks of relationships that we navigate. And by relationships, I don't mean just your friends or your family. I mean the systems that you engage with. It may be the university administrators. It may be institutions. It may be governments. It may be technical systems. It's a bit of a challenge to think about Zoom as being something that constitutes you, but give it a minute. Here's the thing. The shaping is never unidirectional. What we see around us, from global warming to these bewildering technical systems, are both condition and effect of these relationships. As my dear friend and colleague Miguel Sicart likes to say, we are what technology lets us be, and technology is what we make it. Relationality presumes structures of relationships that can support different values. Autonomy, privacy, togetherness, community, these are all enabled by our relations. We afford each other privacy. We support each other to achieve things. There are times when supporting relationships allow people to express themselves in particular ways, and other times, contexts and situations where these expressions can get stifled. Every relation is defined with a bunch of implicit and explicit obligations and responsibilities that we perform and fulfill as part of relational negotiation. There are expectations that we have of each other and of all the entities we engage with. Sometimes these expectations are fulfilled, sometimes exceeded, and sometimes they fail entirely. I were to not show up today to give this talk, I would be failing quite a lot of expectations. And this failure would have different effects in my relationships with pretty much every one of you. Okay, well, but what does that have to do with AI and ML systems? Isn't that just human stuff? Well, we're trying to create autonomous systems that can function in our world. These systems take part in these relations, in these entanglements that we are all part of. And yet we keep designing technology to be a part of kind of indifferent collectivity. GPT-3 doesn't care what effect its actions have. Well, it can't, it's a system. But OpenAI, its creators, of course, only care about some things and not others. They do care about their bottom line. But neither GPT-3 nor OpenAI in designing it take on a kind of burden of care. They don't design their systems to incorporate the kinds of responsibilities and obligations that relationality entails. Instead, AI systems are created with the solution of rationality and idealized market systems. We think about rationality as a form of autonomy. This idea that people are autonomous entities that can think for themselves and make decisions. We would like to design autonomous systems. Now, AI and machine learning systems are deterministic. They're deterministic in that they are designed to detect patterns in very particular ways. When technology is designed deterministically to intervene, it's designed with the assumption that the world is unchanging or will not change. These systems have very lots of difficulties when the world so radically changes or changes suddenly in unexpected ways. So the discussion of true AI being autonomous is an interesting one, where the notion of autonomy can be used to distinguish type of action from completely predetermined, completely constrained, to somewhat unpredictable by its creators, but of course still determined through prediction obtained by the systems themselves. So now that we have systems that are so complex that they cannot be explained, we have what Campolo and Crawford call enchanted determinism. The idea that we have systems that somehow perform ideas, that perform magical processes so that they can be better than human. Although your convoluted neural network will still have a problem identifying whether you have a dog or a cat sometimes. How it does that is something that its creators may not be able to explain. Models are typically built with the assumption of an unchanging world. They're built with the assumption that they do not have any effect in the world and thus don't change it, which is a strange set of assumptions because they're intended to change the world. The problem with thinking about autonomy and thinking about determinism is the idea that we build these systems for rational autonomous selves. The idea of a rational autonomous self is the key to considerations of consent. For example, every time you click a button when it says, this site wants your cookies, would you like only the required cookies? Were you okay with more cookies? This is all about consent. This is all about you being able to exercise your autonomy, making that autonomous statement. But this is a rational ideal, but it's actually extremely difficult to achieve. Many AI systems are created with the belief in a fully deterministic account of human behavior at the same time. That all behavior can be broken down into constituent parts and analyzed for cause and effect. That's how they're supposed to be able to predict you, be able to personalize, be able to support. And yet autonomy in Kantian terms is the capacity of an agent to act in accordance with something more than just the shackles of the ordinary. It's going beyond the immediate desires. It's going beyond determinism. Seems problematic. Now, here we are stuck with this notions of rationalism and autonomy. What does it have to do with relationality? Well, Here's the idea. Jennifer Nedelsky, whose quote I used earlier, argues for a concept of relational autonomy. In her terms, our relations are a source of autonomy as much as they're a threat to it. For Nedelsky, autonomy is a mode of interacting with others. It's a capacity you develop through your relations. It is expressed through exercise of judgment. This approach focuses on the mechanisms of judgment, the necessity to take into account the perspective of others. From a relational point of view, the act of exercising judgment is an expression of autonomy. Judgment is a necessary reflexive process because it requires reasoning through alternatives and ascertaining available knowledge and understandings, your own and relevant others. So because judgment must be exercised, it's an exertion. It requires thought, reflection, consideration. It's ultimately intentional and it's deeply reasoned. If relational autonomy is expressed through judgment, then focusing on mechanisms of judgment is an important step. How judgments are made is important. Judgments that people make and judgments that systems make. What gets taken into account, how, when, and by whom are important questions when we design systems in the same way as we make any kind of judgment. Now, the thing is this, in human relations, no matter how egalitarian or how equal we want to be, hierarchies of power are inevitable. They're inevitable all the time. We negotiate it all the time. But the difference lies in how these are organized. Hierarchies of power don't have to be relations of domination. Just because I happen to be right now in a hierarchical relationship with many of you, I am the speaker and you have to listen. That does not mean this is a relation of domination. This is not how the seminar is designed. In that sense, we need constructive forms of power relations. Nedelsky argues that the relational vision of autonomy is a way to ensure that everyone is treated with respect. In that sense, AI systems are best analyzed in terms of how they will structure relations. As infrastructural systems, as well as agents that take part in relational engagement. The demand for explainability, for example, is one move because of the ability of an autonomous system to withhold information about why judgment is made. This withholding of information is a relation of domination because it puts people whose data are being assessed in a subordinate position. If we think of it this way, then we have many different reasons for why and how we need to design the kinds of relations that we create when we make autonomous systems. So my final thought is, what does it mean to design AI as a relational infrastructure? What if we design AI systems as relational agents? The questions that we need to ask are then, what are the rules and conditions of the give and take of relational practice? What norms and expectations must be developed? What responsibilities are engendered in these relations? These are all relational concepts. Because the fact is that if we're going to design systems that are going to function in the world, then can we design them to support greater capacity for autonomy and dignity for all involved, instead of the kinds of relations of domination that we create now? The key then is that if we design AI as relational entities, if we're able to conceptualize autonomy in relational terms, then maybe we can design them with relational entanglement as a source of autonomy. This means we must think about the rules and these conditions of give and take. We must think of the systems we create in a relational context. Thanks.
Thanks so much, Irina. That was a really fascinating place to sort of leave us on a knife edge about what this actually means in practice. And I think that we had 2 questions from early in your talk that perhaps allow us to focus on those kinds of issue. Rachel asks, she says, is there not an issue with the sources you're drawing from, namely that it's cherry picking the worst examples of the state of the art? And data feminist approaches would suggest that yes, there are significant issues, but actually there are a lot of hidden examples that just work and do not attract attention. And Syed Mustafa Ali here says, focus on failure is important when thinking about that which is not equal, but it really is a failure. Is it really a failure or a mirroring of social reality? And I think that gives you a really good opportunity to come back on this and look at, you've talked about what's horrible. Are you finding ones that have been designed with relational sensitivity, and what would you like to say about those?
Thank you. Thanks, Anne. And thank you, Rachel and Saeed, for the questions. And those are really great questions. Now, here's the thing. There are many good uses, potential uses, and actual uses of good systems. And I actually spent some time trying to find very positive examples. And there are some positive examples. The unfortunately obscured example that you saw, the ability to use machine learning to actually do the kind of work that allows people to think about and to actually make much more reasoned and informed decisions about environmental impact of particular practices is a useful system. The Google system that I talked about, that's not a horrible and it's a complete failure example. The system actually works in some cases and not in others. And it points to the fact that things developed in the lab are not just slam dunk and it'll work everywhere. And we know these situational issues. We know the problems of embedding and situationally in situationally appropriate ways. So in that sense, the failures, I think, are the reflection of certain kinds of social reality, but they're also they also demonstrate and the consistency and the repeated and predictable nature of these failures demonstrate the problems, demonstrate that there's something systemic and deeply problematic in not just each particular system, but how we think about creating the systems and what's their purpose in the first place. And that's where I think it's important. None of this is just, we should never do AI. All of this is just that we really need to rethink how we think about it and how we develop it. Because it definitely has potential. And it definitely has many positive impacts. But the negative impacts that are exhaustingly the same over and over seem to indicate something is broken fundamentally.
We've had one more question come in, so thank you for that answer. I'm going to offer it you while Michael gets himself ready. And it's from Layla Hogarth here, and he says, do you think that it is the implicit articulations of the maker's values that guides all system design as well as any construction of relations? But I'm going to ask you to be really concise because Michael is just setting himself up. So what would you say to that, Irina?
I think it's the maker's values, but it's not just the maker's values. I think in many ways, computer science as a whole has an ontological problem of how we think about what do we mean by developing technologies. And these ontological commitments are the ones that are being consistently challenged. I think individual makers are part of a set of ontological commitments that are shared very broadly that have been consistently challenged for the last few years. And so I don't think it's just an individual problem. I think it's very much a broader set of issues.
Thank you so much. And your work is done. You can relax now, but we're handing over to Michael, who is going to go into something a little bit more specific, but I think take forward many of these themes. So let me give Michael the introduction that he deserves. He's a master inventor at IBM, working in the AI interactions group at the at IBM Research AI, where his work focuses on the human aspects of data science, again, ethics and values in applications of AI, metrics and analytics for enterprise social software applications, and particularly employee engagement. So can I hand over to you to take these issues forward, Michael?
Thank you so much. And thank you, Irina. That was a wonderful talk. And I think some of your themes will be echoed in this talk. And this talk is a little bit of scholarship sandwiched around a rant. And I'll announce the rant in case it's not recognizable. We're beginning with, it's a talk about forgetting and sort of institutionalized forgetting. And so I wanted to begin with Leith, who in the Western tradition is the goddess of forgetting. And so here's one of many, many pieces of poetry. Around our tent, the old simplicities sigh sleepily as Leith, trying to get in. We'll wake up blank-brained as water in the dawn. And so I'm concerned about when we remember things and when we forget things in data science, and particularly in machine learning. And to make the slides more readable, we will not see Leith again until the last slide. So to begin with, people think of forgetting as possibly a good thing. I'm sorry, I need to get the, I'm having Zoom issues here. Now I can see what I'm doing. Forgetting considered beneficial. So forgetting is an aid to memory for what matters. You don't want to remember the stuff that doesn't help you very much. And people have introduced various formal ways of thinking about forgetting. There's the object of forgetting, the thing you forget. The obliviating force, the thing that makes that knowledge oblivious, that causes you to forget, and engines of forgetting that work in partnership with the obliviating force to create forgetting or to remove something from knowledge. And the notion also of a forgetting community, a group of people. We might think about a data science team as a forgetting community, people who collectively forget things or agree to forget things. And some people have even referred to the notion of forgettance as the equivalent, as the opposite of remembrance. And so various people have said forgetting is an important part of memory work. But forgetting has also been considered to be harmful. Proctor and Schreibinger said, why don't we know what we don't know any longer? And it's kind of frustrating. And in the knowledge community, of course, it's very frustrating because we used to know something and now we've forgotten it and maybe we still need it. And so let's look for a moment. Collective forgetting refers to how states and citizens selectively remember, misremember, and disremember to silence and exclude alternative views and perspectives that counter the official discourse. I'll be talking a bit more about the official discourse later. So we can think also about how forgetting works even when we think we're remembering. Here's de Chateau talking about map-based path tracing. The operation of walking can be traced on city maps, but what these actually give us in part is the absence of what's been passed by. All they give us is the trace. The trace left behind is substituted for the practice of walking. And so sometimes that's necessary, but sometimes that's harmful. In more familiar theoretical framing, we can think about data work, especially the notion of invisible work from exactly the feminist data science book. D'Ignazio and Klein said, what gets counted counts. And so if we forget things, we're no longer counting them. And as you'll see, I think we have severe troubles that way. Starr and Strauss talked in a beautiful paper, talked about invisible work and the relationship between visible and invisible work and how people, organizations decide what is visible and what is invisible and how those transitions may or may not happen. The other lens that I'm using, and some of you know this from my own work, is the notion of human-centered data science led by Cecilia Aragon in a series of workshops and papers, and soon a book, how data science makes crucial and often invisible, how people in data science make crucial and often invisible impacts on the formal work of data science. And of course, if we understand that, we can make better work in technologies reflecting the human role. That's going to be a big theme here. And in a paper from us, people create data so that those data will become fit for purpose, fit for analysis, potentially fit for a particular type of analysis. And in doing so, we make some things visible and some things invisible. And if it sounds like I'm saying the same theme over and over again, it's because I'm saying the same theme over and over again. But this can lead us in many ways to sources of bias. And I'm particularly interested in what people of goodwill do that nonetheless results in bias. And so there's a kind of a view in much of the fairness literature that the data made me do it. We have a biased sample, we put it through our innocent software. You can tell that phrase is going to change in a minute. And the outcome is likely to be a biased outcome, despite the innocence of the software, because the data were the problem. And if we're at IBM, we test for bias in the data, and some other places do that too. But what if the software itself is biased? And I will be talking now about how bias creeps into the data science software, partially the model, but especially the pipeline that surrounds the model. And we already know this from techniques like lasso, which deliberately, specifically, selectively forget certain predictor variables. And a very recent argument by Narayanan and Wang that said that certain core algorithms in most pieces of machine learning modeling, like argmax, selectively forget certain records. And in many cases, of course, those certain records are also persons, are also our friends and loved ones. So Bowker said, and Gittleman echoed this in her famous book, raw data is both an oxymoron and a bad idea. The data are always cooked. The question is, how do we cook it? And that's what I want to look at, cooking practices. So then here comes the rant part. I'm going to show you, I'm going to build a forgettance stack in machine learning, beginning from early stages of machine learning up through to the point of sort of completion. And I'm not going to talk about each one of these papers, but the papers here become the basis for the argument that we're making. So here we go. Early on in machine learning work, there's often a measurement plan. Pine and Labaran talked about this. And the measurement plan can contain an implicit politics. Certainly, it makes a bunch of decisions that are a priori to the analysis of the data and even to the choice of the data, like what's a data? What qualifies as the data that we're interested in? How can we measure the things we're interested in? And these measurement plans often are made and then at least partially forgotten when people begin to go and get the data. And Hélène Billis talks about how data are obtained. She says sometimes we discover data, sometimes we capture data. Capturing data, of course, sounds like a very human active process. We find the data, we do things with the data. Later we'll hear about disciplining the data. But the discovery of data is also a human process because, remember back to the measurement plan that tells us what a data is, someone has to decide that data are data and thereby discovering it. Discovery is always done by someone. It's not an abstract process. Then we clean the data, and often in cleaning the data, we get rid of things that don't quite fit. We might get rid of outliers, but our outliers might be our sisters and brothers. We replace missing value with an imputed value that comes from someplace, but then we don't really think too much about how we imputed those data, the missing data. We just sort of do that, and we've already forgotten where the data came from, and we may have forgotten the measurement plan at this point. Then we curate the data, which in some cases means figuring out which class certain things are, or disciplining the data. This is a term from Helena Mentes. We discipline the data until they are fit for use. And I'm not saying anything is evil. I'm saying this is the way that the work is done. And then we engineer features. And I want to tell a quick story. I do have time for a quick story. A very kind person, a very good person, told me in 2019 about the feature that he had engineered for the bank loan application machine learning problem, which was what everybody cared about in IBM in 2019. And so in order to grant or not grant a bank loan, you need to know some things about the borrower. And so he thought, well, I need a measure of employment. So I will take the number of weeks that you have worked in your life, and I will divide it by the number of weeks that you have been alive. That's a percentage figure. It's a percent employed figure. What a simple predictor. And as I said, this is a very nice man. He never would want to hurt anyone. And he didn't see that this certainly carries an age bias. I was older than him. I would have had a higher figure there simply because I've been working longer, because I've been alive longer. it would have disadvantaged him, but also, of course, it would disadvantage people who had to take time away from work for caring responsibilities. And you know, and I know that mostly falls on women in the Western world. What do people say in the United States? Other countries have safety nets. The United States has women. So my dear friend's lovely feature discriminated against two classes of users, and he had no intention of doing that. And he was appalled when I showed him that and changed it. Then we label or annotate the ground truth values. These are the things we're trying to predict. And as we showed in our Chi paper this year, that can be done in a very straightforward and pre-planned and sort of lovely, makes sense, it'll turn out okay method. Or it can be a series of revisions and sort of planned iterations, or it can be a mess. And sometimes it's kind of a mess. Sometimes it's constrained by, often it's constrained by resources. How much time do we have? How many people do we have? Especially in the cases that we were looking at, in which we needed expert judgment, not crowd market judgment. Can you hire enough physicians to label the electronic health records? Can you hire the right financial analysts when you're trying to do very rapid processing of, and this is not a joke, 4 billion records a day, that a small number of which contain evidence of fraud. And so annotating things actually is a big source of noise, but at each stage in this process, we think, well, everything below this step must have worked fine. And so we're gonna do the best we can in our step, and then we'll hand it forward. So we hand it forward, and somebody with more like a data scientist or a machine learning engineer title then takes the data, not really paying any attention to all of the uncertainty in the steps below this step, and trains the model subject to some of the algorithmic problems that we talked about before, deliberately forgetting certain predictors, deliberately forgetting certain records. And then we evaluate the model, but we also then stick the model inside of a pipeline, and the pipeline, and this is a formal term in data science, the pipeline contains all of the steps that are below the level of the pipeline. So it's not just the model, it's also the data cleaning and the feature engineering and the ground truth labeling. And perhaps we inspect it for bias. I hope we do, but not everybody does that. And then eventually it's deployed. And so again, I want to say there's a whole lot of things that human beings do way down this stack. And by the time we're deploying the pipeline, we forget all of those people and all of their diverse roles and their diverse interests and the strengths and weaknesses that they bring to the kind of work that they do. And so then there's this thing that happened, almost like raising a window blind. There's kind of a slapping noise and everything gets collapsed. And then all we see is the pipeline, and it has, you know, good quality measures on it, F1, et cetera. And so we have a sense of how good it is from that formal point of view. And we briefly remember all the people who might have been involved in working on that and all of the points that they might be able to tell us about in case something goes wrong, but then we forget about them really. And it's just the pipeline, and it's just the person who has the pipeline owns the pipeline, and that's it. And how much forgetting have we done in there? How much obscuring have we done of reasons to be cautious, reasons to doubt things, reasons to go back and reconsider when things begin to look not so good. So I'm going to do two versions of before conclusion. And here's the innocent version, kind of like the innocent software. Borrowing from Waugh's Brideshead Revisited, my theme is memory, that winged host, for we possess nothing certainly except the past. Oh, and I see that I didn't do my highlighting right. And so Halbach has written that memory is a social process, things that people do together that links people and things through time in the process of shaping history. Oh, history, that's a really big word from Mills. So let's remember that memory is now shaping history. And of course, if we've read Orwell, we remember that all too well. And organizations also have dispositional practices to select which memories they want to preserve. And of course, the inverse of a dispositional practice is the things that we don't remember. And I just showed you in the rant part of the talk, or maybe the entire talk is a rant, how many of those human practices and their consequences we've chosen not to remember and not to preserve. Memory practices are part of a scientific infrastructure, that's true, which can, in some cases, tell of an idealized past, which is established through things that we think we're doing well, protocols, technical devices, etc. And again, coming back to the point that I made in an early slide, forgetting is a way of remembering what matters. And so in this innocent version, we remember the stuff we should remember, and we forget the stuff that we don't need to remember in order to clarify the stuff that we do want to remember. That sounds nice, but I want to talk about motivated forgetting. Lyotard famously talked about the grand narratives or the meta-narratives of scientific objectivity and inevitability, and some of the people here in this session today have contributed to this discussion. That grand narrative, of course, makes us think that machine learning and data science give us the correct answer and moreover are a perfect lens onto reality. And of course, you know, and I know that what data science often does, and machine learning in particular, is to give us a pretty fine lens on the past, but nothing about the present or the future. It just is a way of taking the past and redoing it. And that's true of the data, and that's true of the human practices that shape how we process the data. Not always, but sometimes. So I'd like to claim that we engage often in selective forgetting. We keep the data and a bit of impersonal metadata, but we discard the non-conformant small data, which again could be our brothers and our sisters, could be the communities that we care about, could be ourselves. We discard the non-conformant small data in the surface of the conformant big data. We discard anything, any additional information that looks human, that might reveal human fallibility in data science. The meta-narrative requires that it be objective, and so we have to not know anymore how people made it, how people made the data. Melanie Feinberg has just a wonderful series of papers on data as a medium of design. And so we make the data, and then somehow the data turn into truth. And we know while we're making the data that they're not truth, but then we forget. And so I would like to claim that there's a great deal of motivated forgetting that happens in data science, and especially in machine learning, by forgetting communities, which are in some cases the team that does the work, and in some cases the industry that relies on the team that does the work. Counter memories, the things that would contradict this, are rejected through a process that Meskel has called negative heritage. So this is the other aspect of dispositional practices that we talked about before. We would prefer not to know certain things by the time we're done with our work, and there are abundant technical and human practices methods for making sure that we forget them. And so people have talked about a vocabulary of remembrance, and I'm not going to go through all of these, there isn't time, but you can glance across these and see there's the person who remembers, there's the thing that's remembered, there's the reason for remembering, and so on and so forth. But there's also a vocabulary then of forgettance, which is worth thinking about. There's the person who forgets, or the team that forgets. The thing that is forgotten doesn't really have a formal name. It may be, maybe those things are amnesiae, I'm not sure. How do people forget? Through an obviating force, operating through engines of forgetting. We talked about that before, producing the phenomenon of forgettance, which is the topic of this talk. People even talk about a skill, forgettery, the capacity to forget. But if we think about this in the context of invisible work and articulation work and infrastructural practices, Michael checks the time nervously. Yes, I can talk about this. We know that each step needs to be done, but often we don't really seem to care about who does that step or how that step is done. It becomes another kind of God trick from Haraway and from Marcus's recent reinterpretation. We see everything from nowhere, actions occur from nowhere, actions are not taken by anyone. It's a meta-narrative, it has to happen that way, it happens. And you and I know that's not true, but in terms of the way that the field works, our practices encourage us to think that way. Our practices encourage us to do the God trick. And so I would claim data science works as a series of forgettings. We already talked about the kinds of things that are forgotten, but also then as a series of erasures. We erase the stuff we don't want to know. And so in place of the vocabulary of forgetting, I'd also like to talk about the vocabulary of erasure. And so part of what we do in data science is we erase the stuff we don't want to know. We erase the stuff that we erase the things we didn't want to do the way that we did them. We erase anything that argues against the meta-narrative, the grand narrative of objectivity and inevitability. And so last slide, I'd like us to be thinking about forgetting practices in the data sciences. And here I'm borrowing very much from Bowker's notion of the memory practices in the sciences. Yes, we have those too, but I think forgetting practices turn out to be very important in data science. And so what scope of forgetting is useful to whom, when, and for what purpose? Forgettance and remembrance are infrastructural practices that people do, and I'm not going to read all of those rhetorical questions. They're also, as infrastructural practices, things that happen through technologies. And so I'm hoping that this becomes a way of beginning to look at forgetting and forgettance in these technological contexts, so that maybe someday we can calibrate our forgetting and our remembering in ways that are ethical and produce social justice. And thank you very much.
Thank you, Michael. And I was made to think of some parallels with the way that perhaps Hannah Arendt or Sigmund Bauman talk about bureaucracy and that kind of distributed responsibility, and how this really speaks to that, only in a completely new context. Really, really interesting. And we have a question here. Mirabelle Jones says, thank you so much for your talk. How do you think this idea of forgettance relates to error as opposed to bias? Normally in machine learning, students are taught to reduce error. How can we know what to forget, especially considering proxy data that might help inadvertently surface certain data in the outcome of the model?
That was a lot of questions. Could I hear the question again? I'm sorry, there were so many.
Yeah, sure. And you might be able to look at it in the chat as well if you open your chat, because it's not too far along. So just saying, like, normally in machine learning, students are taught to reduce error. How can we know what to forget, especially considering proxy data that might help inadvertently surface certain data in the outcome of the model? Any bit of that, I think. We've not so much time. But
there's multiple kinds of error, and we're currently wrestling with this in IBM research as regards explanations and explanatory AI. There's the error that happens, that's sort of the quantitative statistical error. How many things did we misclassify? There's the error that happens because the software is just plain wrong. And so if we're trying to do an explanation, sometimes the explanation is you didn't get a bank loan because you don't make enough money. But sometimes the answer is, well, you didn't get a bank loan because our software really messed up and it hurt you and we're sorry and maybe we can fix that. However, in most bank loan applications, neither the customer nor the loan officer has access to that error or is in a position to do anything about it. So, so in some ways that grand narrative has built into it the, not the lack of agency, the de-agencyizing, there's a word for that Irina knows that I don't, the removal of agency from the most proximate people who touch the system and who are affected by the system. That's not a complete answer to the question, but that's at least the beginning of an answer. And so proxy data can help. Some proxy data we want to exclude from what we do. Like, for example, we don't want the algorithm to think about the race of the person applying for the bank loan or the race of the person whose jail sentence is about to be determined, but we do want to keep those data available for critique on the system afterwards. The problem is, of course, there's also other kinds of proxy data. Zip code or postal code is a very good way of representing race without representing race, and so on and so on. And so the proxy data are also complicated. That's also not a full answer, but it's, I should stop and hear another question.
Well, we've got a response from Mirabelle Jones, who says to be human is to err beautifully. So I think that was in partly in response to that. I think we might have to keep going onwards, actually, okay, Michael. But we've had a good chat with Irina's paper in the chat. So if you can watch the chat, then I think that will probably give you some more things. And it reminds me, I don't know if you heard about the scandal of our post office. Lots of very small post office operatives kind of all over Britain suddenly found themselves being tried for fraud because of a system that everybody insisted on believing in, despite the fact that it was identifying them as criminal when they hadn't actually taken money out of the system. So if you don't know that, I will share it with you. Yes. Now we should go on to Lorna McGregor, and let me give a bit of an introduction here too. we're the pleasure of having here a professor of international human rights law and the PI and director of the Human Rights Group Big Data and Technology Project, working at the University of Essex in the Human Rights Centre. So coming very much from the side of law, and a very different kind of approach from the ones that we've been hearing about, because I think Michael and Irina would probably agree that they were at least tangential to human-computer interaction. So we've got someone here who's focusing on human rights, data analytics, new and emerging technologies, but also detention under international law, access to justice and remedies under international law. So a very different perspective here. And may I please welcome Lorna, who you are not going to use slides. So please, the floor is yours.
Great. Thank you so much for the invitation to participate in this really fascinating event. So as you said, Anne, in the time that I have, I'm going to focus on the human rights impacts of the design, development and deployment of new and emerging technologies, or AI technologies. And I'm going to look at some of the regulatory questions that surround the discussions on the role of these technologies in our lives. So I started working on the human rights impact of what are broadly described as AI technologies about 7 years ago, when we first started writing our first application for the Human Rights Big Data and Technology Project, which is a multidisciplinary project which looks at the human rights impacts of these technologies. And at around the time that we started our project, what we saw when we were looking at what was happening in the field, and particularly in the human rights field, what we saw in the first few years was that framing the nature of harm was incredibly challenging. And the reason it was incredibly challenging from a human rights perspective was that there were very few tangible stories about how the design, development and deployment of new and emerging technologies were actually impacting human rights. That didn't mean that harms were not happening, but the lack of transparency about where and how AI technologies were being used, particularly in decision-making and in service provision, meant that even if a person had been harmed, they didn't necessarily know that something had happened to them, or they might have experienced a harm, but they didn't necessarily know that AI technologies had anything to do with it, that they were being used in a decision-making process or in resource allocation. And that meant that human rights harms had to be framed in the hypothetical. And that's something that we haven't been very used to doing in the human rights field. We're used to storytelling. And so it made it quite difficult for human rights advocates to have purchase and to convince policymakers of the seriousness and the scale of harm potentially already happening or at the risk of emerging in the near future. And this was made even more difficult because the focus on harm was often on privacy, and privacy narrowly understood as data leaks and data breaches. And that had two consequences. First was that harm was just not seen in a very serious way. You often heard people talking about, well, it's just privacy. Privacy is dead. These types of narratives. It also had the consequence of data protection legislation being seen as a solution. So at that point, the level of intrusion of AI technologies into people's lives through the insights and partial inferences that could be made was underestimated. And what was also underestimated was the critical role of privacy as a gatekeeper to the protection of other human rights. So it was really a slow start in being able to articulate how serious it is to violate privacy in the digital age, and also the role of privacy in protecting other rights. So a really slow start in capturing and framing the problem. Then, thanks to the incredible work of investigative journalists, civil society actors, data scientists, and a range of other disciplines, more stories started to come out into the impact of AI technologies. And as we've already heard tonight, a lot of that focused on the impact of AI technologies on discrimination and inequalities. So there started to become a narrative within human rights of understanding how discrimination can be baked in to AI technologies like algorithms due to bias on the data, and often historically biased data on which they rely or on which they were trained, who trained the data, the way in which the technology functions, and the production of discriminatory outcomes. And then from there, we started to understand that it was not only the technologies that were themselves presenting risks to human rights due to the way in which they were designed or developed, but the focus then started to turn more squarely to questions of who was designing, developing, and deploying the technology, and for what purpose. And viewed through that lens, we started to see that many of the areas in which technology was being used were areas in which people may already be experiencing marginalization. So, for example, in the public sector, Crawford and Schultz point to the introduction of AI technologies as targeting the services considered the most expensive. And I'm quoting them, which often include the most politically, socially, and economically marginalized communities who, because of their status, are more likely to need greater levels of support, end quote. So these areas where we were seeing AI technologies being introduced were areas in like criminal justice, as we've heard already, social security, housing, health, education, employment. So from there, we started to see that the human rights concerns were not just in relation to how the technology itself was functioning, but also how it was impacting human decision-making and service delivery and replacing or reconfiguring existing approaches to decision-making and governance. And that gives rise to concerns of governance by AI and the deepening and amplification of existing human rights challenges. And the potential that people are left feeling as if AI is being done to them, including in really important areas of their lives, without transparency and without consultation. And so that's led us to a position now where we can see that there are core human rights challenges with technology, such as privacy, such as discrimination. But we also understand now that technology itself and its deployment does not affect us all equally. And just as much as looking at how the technology works is important, we need to understand who is deploying it, why it's being deployed, and within what context. And that very much connects to Irina's points on relational infrastructure and power. But at the same time, capturing harm continues to be a really huge challenge for human rights, particularly trying to capture the scale of harm, the interconnectedness across groups, also challenges in capturing negatives, where people don't exercise their human rights, what's often called the chilling effect, because of the concerns about the deployment of AI technologies. And we've very much seen those debates in relation to facial recognition technologies, but also capturing harm in a way that gives enough evidence and proof to be able to exercise the rights to access to justice and remedies and try to get accountability for harms that are being caused. And that really turns to the questions of frameworks and regulation, which I was asked to touch upon. So from that contextualized understanding of the potential harm of AI technologies, then our question is, and continues to be, how do we effectively prevent harm from occurring and address it where it materializes? And within the literature, we do see a lot of authors cautioning against a rush to regulation and pointing out just because a technology is new, it does not mean that it exists in a legal vacuum or that existing frameworks do not apply. And as I've already noted, data protection legislation like the EU General Data Protection Regulation really is a critical starting point in the governance of AI technologies. And certainly from a human rights perspective, we've consistently made the argument that existing international human rights standards and norms offer an important framework for states and businesses when they're designing, developing, and deploying AI technologies. And the reason we argue that is because international human rights standards and norms give concrete definitions of harm and also tests for establishing when harm violates human rights standards. For example, when does bias constitute unlawful discrimination? Or when are restrictions on rights, when do they amount to a violation? And when can states show that they're actually pursuing a legitimate purpose and that they're necessary and proportionate? So they help us with these ideas of balancing. We have also argued that international human rights standards establish states and obligations and businesses' responsibilities. And that's really critical in relation to the whole life cycle of AI technology. So right from the conceptualization of an AI technology, looking at prevention, oversight, monitoring, and remedies. And international human rights standards and norms have a lot of important safeguards and also some red lines where we argue that because the purpose of the technology or its effect has such a significant impact on human rights, it's not possible to use it. That's where there's a red line. And that either means you have to go back to the drawing board and redesign the technology, or you have to introduce safeguards in order to protect human rights. So really for a number of years, people were focusing on implementing existing laws and existing regulations and existing standards. And I think there's still a long way to go in actually effectively implementing what we already have. And we've certainly started now to see some important judicial decisions where courts have been applying international human rights standards to specific use cases. So we've seen a court in the Netherlands highlight the special responsibility of states when applying new technologies to strike the right balance between the benefits the use of such technologies bring, in this case, as regards preventing and combating fraud, and the potential interference with rights on the other hand. We've also seen a lot of attention to human rights impact assessments as a means of identifying human rights harms, and that has predominantly been in relation to businesses, but increasingly we're seeing arguments for the use of impact assessments within the public sector. And we've seen some voluntary state and business AI strategies where some human rights language is picked up on, but it tends to be quite inconsistent in terms of which human rights are referred to, often not referring to context like social care or education, and often missing out key accountability and remedial mechanisms. So we see some pickup of human rights with the existing approach, but definitely not a full implementation. And from there, I think what is increasingly clear is that despite the risks with regulation, more direct regulation of the design, development, and deployment of these technologies are needed. And from there, we've started to see proposals for algorithmic accountability acts. We've also seen in the EU, the proposed AI regulation. And we've also seen a range of technology-specific regulations, such as the moratoriums proposed on high-risk technology like facial recognition. And I would say that some of the key features of these debates globally are that, again, data protection and privacy laws and their implementation and practice continue to be a central baseline question that we just absolutely can't lose sight of. Another baseline is around transparency. It remains a significant problem, and it will remain very difficult to actually be able to exercise human rights and protect human rights if we don't actually know which technologies are even being used, for example, in the public sector, which is why there are calls by organizations like Algorithm Watch for public registers. There are a number of proposals for mandatory human rights due diligence, and it's often focused at tech companies, but it's equally as important in thinking about operationalizing states' human rights obligations. And mandatory due diligence is not just about conducting impact assessments, which often get the attention, but it's about ensuring that company and states' internal policies and processes, including internal oversight mechanisms, leadership, consultation with affected groups, ensuring that all those processes are human rights compliant and really looking at the human rights impacts of technology throughout the whole life cycle and throughout the whole business or state operation. So there are these important debates going on, but I think there are also other important issues that we need to look at when we're thinking about regulation. I think within the public sector, a key and often given not as much attention as it potentially should, is the regulation and oversight, not only of public use of technology, but also procurement and the relationship with the private sector. So looking at public-private partnerships and the involvement and outsourcing to technology companies of public functions. As I already mentioned, red lines, I think, are critical in establishing when certain forms of technology should not be used. And again, connecting to Irina's presentation, at the business level, there is now much more attention to business models and platform power. And that again comes alongside the need for much more of a focus on strong and effective regulators and remedies so that individuals affected by these technologies can actually know and exercise their rights. So what I think it is clear is that we can't expect regulation to equate into one overarching piece of legislation, given the range of technologies, the context, and the potential human rights harm. We're likely to be looking at a mix of AI-focused regulation like we're seeing in the EU, and then actor-specific, technology-specific, and sector-specific pieces of regulation. And I think, you know, in the context of this summer school, what really needs to be highlighted is that people need to be centrally involved. So again, in these ideas of relational power infrastructures, what we often see is that AI is just being done to people without proper consultation and without participation and proper debate on the place of these technologies within our society prior to their deployment. And there's a lot of conversation about participation at the moment, but I think it's one of the most essential things to look at how it can be done meaningfully ahead of time. I think I'm at time, but just to really quickly point to some of the more positive notes that have been raised. I've talked a lot about the negatives. And I think these negatives, particularly when you're thinking about areas that were really important in people's lives, these negatives and these risks are present on a range of different levels. But even where we see technology having the potential to be transformative to people's lives, we have to think about these risks as well. So I do a lot of work in relation to the use of technology in relation to older persons. And I think there's a lot of interesting literature and practice emerging that shows that the ways in which technology could potentially enhance the ability of older people to live and participate independently and in the community. So moving away from the idea of large-scale care homes, for example. But the risks that I'm describing, as I said, are present even when there are these potential opportunities. And in order to address those risks, it won't only come about by addressing risk to technology. So for example, in the context that I'm thinking of, if you have technologies which are monitoring for safety and security, there are potential fixes by preventing data from going to centralized databases and keeping the data localized, for example. But some of the most significant changes to open up the potential of technology would come from a vision for social care that is based on human rights. So if you're trying to introduce technology into a vision for an operation of social care, which is about time and task and resource constraints, I think what we've learned from lots of sectors is it's more than likely that technology will be introduced to fulfill those types of purposes. But whereas if we're trying to introduce technology into a vision for social care, which is about autonomy, independence, living your best life, and participation in the way in which technologies are designed so they're fit for purpose and the way they're governed and regulated, it may be that technologies are then able to actually be used by the people who want to use them, again, going back to that important point about consent, as a way to live independent and autonomous lives. But we can't ever abstract technology from the context in which they're being used. So I'll end there, but thank you again for the invitation.
Well, thank you so much, Lorna. And you're talking about an area that's very close to my heart, which is how older people are able to age gracefully with technology. So thank you so much for that. We have a couple of questions, particularly Dahlia has come in with lots of questions. So I'm just going to read out, I think, the key points here and then ask whether Lorna will respond. To what extent is the difficulty around applying conventional human rights frameworks to AI rooted in the fact that these technologies are wrongly but broadly understood to be artificial, i.e. somehow separate from material and embodied realities? To what extent have major companies managed to evade human rights frameworks on the basis of this reputation and discursive framework? Well, let's start with that, because that's a stonker of a question.
Well, I think that exactly gets to the point that I'm hoping to make, and I think a lot of people are making, that we have to understand technology in context, and that it is being designed and used and deployed by people. And so I think, Michael was talking about this too, that we can, I think early on in the debates, there was often this idea, and I often was asked this question of, well, is there less responsibility if we don't know what the technology will do when we put it out into the real world or the wild? And I was always a little bit confused by that question as to why, if you put technology out without knowing what would happen, why would that reduce your responsibility? Because sort of in my sort of human rights view and legal training, that would increase your responsibility if you weren't able to predict and therefore safeguard for the risks that could potentially occur. And so I think that point then goes back to that it's humans that are making these choices, and often very powerful humans. So I think being able to bring us back to that focus sort of answers that question around how can we effectively apply human rights frameworks. But I think they are increasingly difficult to do in a way where we expect states and businesses to look at their general human rights obligations and general human rights responsibilities and interpret how they apply to what they do, and then make decisions themselves on whether they can or can't do these things. I think we need to have many more worked out answers to where the parameters are on what is permissible and what's not, and that be part of a wider society conversation than just these decisions being made internally within states and businesses, and then we have to wait if and until they get to a court to find out whether they have been lawful or not.
I very much appreciated your comments about the need for participation and a much broader understanding of that, I think. Irina has posted a question for you, which is, how much is this about AI technologies and how much is this about the organizational problems in these institutions, the logics of efficiency in new public management and the like, which I think you've touched on. And Dahlia has come back with another one, which is, to what extent do you think that refusal can be the rights-based response? That perhaps it's not always about redesigning or changing who develops and how AI is developed, but that actually the notion that AI is not an appropriate solution for particular spheres of life. And although they're not directly linked. It seems to me that they probably are in terms of how one might answer that. So can I give you another moment to come back on that before I thank everybody and wrap up?
Yeah, so I think on the first question, I think it's both. You know, I think there are problems with technology and how it's being designed, and we shouldn't lose sight of those. But you know, for example, a lot of solutions are often not solutions, but partial approaches to dealing with targeting, for example, online, is, you know, are often connected to, well, privacy. And if privacy was properly implemented, then maybe that would go one way. So I don't think we should lose sight of those, but I do think institutional questions are really critical. Both in terms of how human rights principles are really embedded and operationalized within how institutions function, and I'm a real believer that that has to be a priority, but also in how they approach complex social problems generally, and then introduce technologies into them. So social care, you know, I think is a fascinating area because it's complex in and of itself, and technology may have a role, but unlikely to have a role if it's brought in as sort of a techno-solutionist approach. And I think in relation to the last question, which I've now had in my head and lost, the not appropriate in certain areas. I think that that's a really critical question, and it is being brought up in the EU AI regulation, and it's something that we started to think about in relation to red lines. You know, when should you just never see AI technologies, and when might you be able to see them, but only if there's certain safeguards in place. But I think where we, in the public sector at least, have seen the introduction of a lot of AI technologies which we don't understand and fully know about, is exactly in these high-risk areas. And that's a real concern, to start with high-risk areas when we know so little about how AI affects decision making. So I absolutely agree in that point. It's really important.
Well, and you're getting love from the audience for that as well. And Belen has come in saying we definitely need red lines. So I just would like to thank everybody. Perhaps we can go back to a gallery view here so that I can see all the presenters clearly, and we can thank them, because it's been a really, well, I mean, I've been learning a lot and really enjoying it. And normally when I'm chairing, I concentrate on the chairing, but I've been absolutely captivated by the different approaches and positions that people have taken. And I want to thank everybody so much for starting us off so well on this series of webinars. So if you're somebody who's come tonight, you might want to consider coming to hear. Then tomorrow night we're talking about alternative economies and different ways of thinking about the digital economy. Then we roll into how to manage data more justly. And finally, we've got a Thursday night that's dedicated to design fictions, imagination, different ways of telling the story equitably. And if you're coming to the summer school, which is starting just for our 22 participants tomorrow morning, then I look forward to seeing you bright and early tomorrow morning. And I hope that there's been something in here of useful to you, specifically to develop the questions that you're bringing. So thanks, everybody. I think that's it from us, and Clara and I want to say good night, and the chat has been really great too. So perhaps we should just all linger as panelists and look at all the great comments that people have been making. Thank you so much. But we declare the session closed.